Hi friends, welcome to my YouTube channel. This is first part of lecture number 20 and today we are going to start circuit operation and waveforms of one phase half wave control rectifier with a load. So this is the circuit diagram of rectifier with a load. Here load is inductive and we get output voltage V0 across this load. And this thyristor is connected in series with this inductor L, and this whole circuit is supplied with source voltage Vs. Here Vs is equals to Vm sin omega t, and this is the waveform of Vs. Here thyristor is fired at an angle alpha. So we will study the operation of this circuit in three angular slots. First we will see the operation from 0 to alpha, then from alpha to beta, and then from beta to 2 pi. So first we will see the operation from 0 to alpha. From 0 to alpha, anode to cathode voltage is greater than 0. Why it is 0? Because from 0 to alpha, this Vm sin omega t V is equals to Vs, it is positive. So when this sinusoidal voltage is positive, then positive potential is applied to the anode of this thyristor. When positive potential get applied to this thyristor, then VAK becomes greater than 0. But thyristor is not fired or triggered yet. That's why this thyristor will act as open switch, and mode of operation of thyristor from 0 to alpha will be forward blocking mode. And we know that in forward blocking mode, thyristor acts as open switch. Now when thyristor acts as open switch, then current in this loop is equals to 0. When current is 0, then we get output voltage V0 that is equals to 0. So from 0 to alpha, V0 is equals to 0 and I0 is also equals to 0. Now what is thyristor voltage drop? It is simply equals to source voltage, because when thyristor is off, then this whole source voltage will appear across this thyristor. Okay, so here we can see that this portion of source voltage will appear across this thyristor. Now we will see the operation from alpha to beta. Here at omega t is equals to alpha, thyristor is fired. When thyristor is fired and VAK is already greater than 0, then thyristor get turned on. So thyristor will be in forward conducting mode from alpha to beta. Now when thyristor get turned on, then what happens? This thyristor acts as short circuit. When thyristor acts as short circuit, then voltage V0 is equals to Vs, because the source voltage Vs will appear across the load. So that's why we get V0 is equals to Vs, and that is equals to Vm sin omega t. So what is current I0? To calculate this current I0, we simply apply KVL in this loop. So when we apply KVL, we get I0 is equals to 1 by L integration voltage across inductor dot dt, and we know that voltage across inductor is V0. That's why we will integrate V0 dt, and we get this current I0 from alpha to omega t. So integrate this from alpha to omega t, because thyristor is fired at angle alpha. So we get current starting from alpha. So integrating this, we get I0 is equals to Vm by omega L alpha minus cos omega t, and maximum value of this current I0 occur at this pi. Now an important concept is, in this case we get current up to beta. It is very simple concept, and it has already been told to you in my previous lecture. Whenever there is inductor in load circuit, then we get current up to beta. So we get current up to beta, and output voltage V0 we get till we get this current I0. So we get output voltage V0 till this output current I0 is positive, and this I0 is positive from alpha to beta. That's why this waveform of Vm sin omega t will appear across thyristor from alpha to beta. And what is beta? Beta is simply equals to 2 pi minus alpha. Okay, so from alpha to beta, and beta is equals to 2 pi minus alpha, this source voltage waveform will appear across this load. Okay, now what is drop across thyristor from alpha to beta? We know that from alpha to beta, thyristor acts as short circuit. That's why drop across a short circuit is equals to 0. That's why we will get 0 voltage drop across thyristor from alpha to beta. Here it is not diode, it is thyristor Vt. Okay. Now we will see the circuit operation from 2 pi minus alpha to 2 pi. So what is the operation from 2 pi minus alpha or beta to 2 pi? So from beta to 2 pi, VAK is less than 0. Here the voltage has already reversed at pi. So that's why it is still negative. So VAK is less than 0. But the current across thyristor has become 0 now. So that's why I0 is equals to 0. And when I0 is equals to 0, then thyristor get turned off. So when thyristor get turned off, it means it acts as open circuit. So when thyristor get open circuited, then I0 is equals to 0 and V0 is also equals to 0, and this source voltage will appear across this thyristor. So here we can see that this portion of source voltage will appear across thyristor. Okay, so this is portion, it get appeared across thyristor from beta to 2 pi plus alpha. Because this thyristor will remain turned off till we again fire it, and we again fire the thyristor at an angle 2 pi plus alpha. That's why from beta to 2 pi plus alpha we will get the waveform Vs appearing across this thyristor. I tell you one more important concept. Here we know that we get output voltage V0 up to 2 pi minus alpha. Why we are getting output voltage from alpha to 2 pi minus alpha? This is because we know that average voltage across inductor is equals to 0. That's why this positive portion must be equals to this negative portion. Only in that case average output voltage is equals to 0. So that's why this pi minus alpha length must be equals to this length. Okay. So that's why we are getting current up to 2 pi minus alpha. So this is all about this video. I hope you like this video. Thank you. Jai Shri Ram.